Hello class. So I hope that everyone managed to download the RapidMiner and you're able to launch and run it on your own computer. In this recorded lecture, I will do a quick recap on the machine learning concepts and the steps that involve in doing data mining and machine learning analysis. After that, in the next recorded lecture, we are going to learn how we can use RapidMiner to build a decision tree model based on a very simple scenario and the data that is available for us in the RapidMiner. All right, to begin with, there are 5 steps involved in building machine learning model. It applies to any type of model, so I do have decision tree model here, but it applies to any data mining process and machine learning processes. So before any task, we have to understand the business scenario. So if we don't understand the business scenario, if we don't understand the business question or the problem that involved in that scenario, we are not able to answer the correct question. So the step number 1 applies to any problem-solving challenges that you're gonna face when you join the workforce. So business understanding and problem understanding is very important. Okay, the next step, which is data preparation and data understanding, are probably the first 3 steps, along with the step 2 and step 3, are the most important steps in data mining process, in that you are going to spend a lot of time to understand the data instances in your project, and you're going to spend lots of time to prepare the data and cleanse the data and prepare it for machine learning models. These steps, as I mentioned, takes a lot of time. Step number 4 and step number 5 are the easiest steps. Once your data is cleansed and ready to be processed by a specific algorithm, building model and testing the model is just a couple of clicks. So that's why usually in the data mining process, we're gonna say that step number 1 all the way to step number 3 accounts for 85% of the total project time. So usually in the business, the data that you're going to work with, they have lots of missing values. There are inconsistent format in your data. So you have to spend lots of time to cleanse the data. So one of the softwares that basically use a lot in cleansing the data is Microsoft Excel. For example, in this class, you learn a lot about text functions. You're going to use those text functions to cleanse the data, to create different columns or variables in your data. So all of those detailed steps probably require another software to be used in the process. Okay, so once you're done with the step number 1 to step number 3, you're going to build different models using different algorithms. And after that, once you build those models, you're going to test the performance of those models. And finally, you are going to deploy the best model in your business scenario or in your company. Okay. So in terms of the modeling, if you have watched the DataCamp video series, we know that we have basically 2 types of modeling. The first one is supervised learning, and the second one is unsupervised learning. In the supervised learning, we have label data, in that we have a separate column for our dependent variable, which is coded, and we know the correct information about that column. And then we are going to use some predictors or features or explanatory variables or independent variables to predict the output variable. Okay, for example, if you are going to predict the house prices, the house price is going to be your dependent variable, and other features such as number of bedrooms, the neighborhood, the square foot of the apartment, and other features related to house can be used as independent variable to train the model. So basically in the supervised learning, we have label data. However, in the unsupervised learning, we don't have any label dependent variable. In other words, we don't have any variable or dependent variable that we are going to predict. However, our aim is to get the broad understanding of the data and to understand how those basically features are related to each other. For example, one of the algorithms that are used basically in unsupervised learning is the clustering. For example, you have information about your customers and their purchase behavior. When you use clustering, you are going to basically divide or split those customers to different segments based on their demographic information and also their purchase behavior. So, for example, you're going to figure out adults, for example, less than like 30 years old, they are more interested to buy like a sports car, and adults more than 30 years old, they are more interested to buy, for example, SUVs, something like that, okay? Or you are going to understand what kind of movies or series are different customers, for example, in Netflix are interested in. For example, younger adults are probably more interested in action movies, and senior citizens might be more interested in watching, documentaries. So you're going to see how the demographic information and other attributes of the customers can be used to segregate them in different groups. So for this class demo, we are going to use a machine learning model, which is a decision tree model. And we could use unsupervised learning, but I think that this decision tree is more easier to understand for you folks. So in terms of the supervised learning, we can have two different tasks. For example, we can use supervised learning model to predict two different classes. For instance, let's say you are in a financial institution and you receive information about a new applicant for a credit card. Based on his or her previous information, such as her age, sex, working, status, and their previous credit history, you are going to say that whether you are going to approve his or her credit application or not. So this is called decision tree models or classification models. The other one is the regression models, which means you are going to predict the numeric values. As I mentioned in previous example, you are going to say how much would be the value of a apartment if you receive information such as the neighborhood, number of the rooms, square foot, and other information. So you are going to use regression models to predict the future values of the home. In order to use supervised learning, we're going to split our data into training set and in validation set. So we are going to run a model on the training data set. So once our model learns about our data, we are going to apply that model in the validation data set to see how our model performs. So basically in the validation data set, we already have the label data and we do have the projected value of the algorithm, right? And we can compare how well our model perform in the validation data set. So we are going to see an example of that in our demonstration. So this is just the broad idea of how the supervised learning splitting works. Usually the splitting will be done randomly. Let's say that we have randomly split our data into training and validation, 70% of data for training, 30% for validation. And the play here is our dependent variable. We are going to predict whether, based on the outlook, temperature, humidity, and windy, we are going to play golf or not. So we are going to train the model based on the training data set here. Once the model learns about the relationship between different variables, then we are going to apply that model on the validation data set. So as you can see in the validation data set, we know the true or correct values of the play variable, which is our dependent variable. And the model, based on how it is trained in the training data set, going to predict yes or no here, right? After that, we can evaluate the model performance in the validation data set because we have the correct values and the predicted or projected values. All right. I mentioned about the splitting data set. So in this class, we are going to use decision tree model. And the reason that I picked decision tree model because it is a very intuitive model for most of us to understand. And there are a couple of advantages are related to decision tree model. It is easy to understand. It is not influenced by outliers and missing values. So as I mentioned, when we are going to build machine learning models, we have to spend lots of time to cleanse the data and prepare the data, right? So the good thing about decision tree models are they are not going to be affected by outliers and missing values. And they are capable of handling both numerical and categorical values, and they are non-parametric method. That means they don't have any assumption about the characteristics of your sample data. So decision tree is quite well, for this demo because we are going to skip the data cleansing and data preparation in this demonstration. And there are some disadvantages related to using decision tree. The first one is overfitting. It means that basically in the decision tree models, your model tends to perform very well on the training data set. It's going to learn very well on the data set. However, when you apply that model on the validation data set, the performance is not close to the training. So we call this overfitting. That means model performs well on the training, but it doesn't do well on the validation data set. And another issue is not fit for continuous variables. So it mostly works better on the categorical data. All right. So this is an example of the decision tree model. So once you build the model, the decision tree algorithm going to figure out the first node that can be used, or the first variable, the most important variable that can be used to split your data into different decision, yes or no decision, okay? And it's going to create a graph like this. We call those green nodes here the terminal node. That means they are our final decision node. And we call these basically pink color nodes decision nodes. So after the first node, which is the root node, we do have other variables that are important in making decision. So the decision tree is going to figure out the importance of every single variable in making decision about whether someone going to purchase a product or not. So we are going to see example of that uh, in our sample scenario. And finally, once we build a decision tree model or any supervised learning algorithm, we are going to evaluate the performance of that model using a metric called accuracy. So in this basically confusion matrix, we do have the true class values, that means whether it is yes or whether it's no, and we have the predicted values of our model as well. And based on those values, we're going to have 4 different classes. True positive count, that means our model predicted correctly and it is in line with the positive value of the outcome variable. False positive, it means that the true value of that dependent variable was yes, however, our model predicted yes, which is false positive. False negative means that our model predicted no, however, the true value of that class was positive. And finally, the true negative means that the model predicted no, and the true value of that class was also no. And based on this information, so we have different numbers here. We can calculate the accuracy of the model based on number of true positive plus number of true negative divided by number of all cases. True positive, true negative, false positive, and false negative. Again, as I mentioned in this class, I don't expect that you understand all of these concepts because they need a class by itself. So don't worry if it is a little bit confusing for you. In the next lecture, we are going to see how the model works, how we can build a model, and once I create a decision tree, it's going to be more easier to comprehend all of these concepts. Thank you very much for listening.